my last episode, I talked about artificial intelligence and I talked about how technology is exploding and the rate at which the technology is advancing is growing exponentially, and how human beings need to adapt to the advancing technologies, and how organizations need to adapt quicker and quicker to advancing technologies. But I did get a little bit philosophical. So today what I would like to do is to see how an organization can adapt to the changing technologies. Now, let's take an example of an infrastructure services team within an organization. Now, usually how an IT organization is designed is that you've got the business functions on the top, and then you've got an IT business enablement function, or you've got an IT business function that essentially supports that particular business function. So let's take the example of marketing and finance and treasury and manufacturing and so on and so forth. So all these are different business functions that support the business. And then you've got accounting IT and finance IT and HR IT and manufacturing IT and so on and so forth. These are basically IT functions that support the specific business function. Now, behind that, we've got an infrastructure services team that essentially supports these IT business functions, right? So you've got solution design teams, or rather infrastructure solution design teams that support these IT business functions and enable them by giving them the infrastructure that they need to host their specific applications. And then you've got your on-premise engineering and operations team. You've got public cloud, whether it's AWS, Azure, Google, or what have you. You've got those public cloud engineering and operations teams that support these solution design teams. Now, these engineering and operations teams, what is the difference primarily? So engineering teams essentially enable new capabilities within the infrastructure. So if there is a AWS engineering team, it would qualify AWS services and make them available for the solution design team to basically use these services and provide hosting. And then you've got operations teams that would make sure that things are operational, business as usual, keep the lights on types of activities, whether it's ensuring that the services are available as required and what have you. And then, of course, you've got many other teams within the infrastructure services team, like you have your security posture management team and quality and so on and so forth. Now, let's assume a scenario where you have a large number of applications in a particular data center and you would like to migrate these applications on-premise to the public cloud. Let's assume that the public cloud that we're using is AWS. Now, there are multiple ways that you can do this. The standard way that we usually do this in is that we throw a large number of people at this project. We start a project by raising a demand and asking for funding for this particular project. And then once the funding is received, then we come up with a sort of Scrum team structure or project management team structure where you've got a steering committee, and then you've got project managers, and you've got solution architects, and you've got engineers who are primarily working on migration, etc. activities. And the larger the number of applications, the larger teams. And these days, there is a new concept that has come in, which is called pods for each. Work together, there might be a quality management team and so on. And you basically work together in trying to understand and assess each application, try to see what are the different cloud services that are going to be needed. They try to understand the disposition of the application. Are we going to lift and shift the application from on-premise to the public cloud, or are we going to refactor it and re-architect it from scratch and so on and so forth? And each pod will basically work on 4 to 5 applications in the upcoming 3 to 4 months, right? And the usual velocity of migrations that I see in the industry is about 4 to 5 applications in 4 to 6 weeks. So 1 application per month. Now, this is all right if you're trying to migrate 4 to 5 applications and it works fine. But let's assume that, you need to migrate 50 or 60 applications in the next 6 months. What are you going to do? You've got a multiple options. First option is throw more number of people, more pods, So let's say 50 applications. one pod will work on 4 to 5 applications in the next 3 to 4 months. So you are going to need 10 pods, each pod working on 5 applications in the next 4 to 5 months. So in about 6 months, you would have 10 pods working on 50 applications, migrating them, in parallel. And we are also going to do an assessment where we are going to take a look at how the applications are interdependent on each other, if there are any interdependencies. Good if there are not any, but if there are dependencies, then they will have to be put into a single pod. And so that's how it works. You've got 10 pods, each pod working on 5 interdependent applications. They do the assessment, they do the migration, they try to understand the disposition of the application. Based on the disposition, if it is a lift and shift, then they are going to lift and shift. If it's a refactor and redesign, then they will redesign the application from scratch and then mobilize the application onto the public cloud, and that's how it goes. One more thing that needs to be considered is that an infrastructure services team is involved in design, engineering, and operations. So there's a good amount of operational costs that is provided. Now, there's one new interesting concept that has come along recently, and I'm not saying that this is my concept, but it's called the Agile Infrastructure. Now, what that really means is that the infrastructure team stops being an infrastructure engineering and operations team and becomes more of a software development team. What that means is the infrastructure is not migrated by people. It's migrated using infrastructure as a code. Basically, is software, right? We use Terraform and other technologies, and we write code that will essentially do the migration for themselves. Now, usually there is a certain amount of automation in every organization, right? Certain amount of automation in every infrastructure team. I mean, if I want to, let's say, get a EC2 instance provisioned on AWS, I should be able to request something on my CMDB, whether it's ServiceNow or whatever CMDB you are using, and that particular request will automatically trigger a Terraform code, which will essentially provision an EC2 instance for me as per the standards. I should be able to specify what size I require, where I need it, what is the landing zone, etc. And it should be able to give me an EC2 instance. But that is a very case-to-case basis situation, right? What that means is that, getting one EC2 instance using automation is one thing, and being able to provision the entire infrastructure for an application, whether it's multiple environments, multiple EC2 instances, multiple services like EC2, EFS, RDS, etc. on AWS, all getting provisioned at the same time, or all getting provisioned as a part of a group of automation code, right? Now, I'm calling it a group of automation code, but in technical jargon, it is also called a playbook. You could basically design a playbook in which you specify a sequence of events happening. You specify a sequence of Terraform code that needs to be executed. You can specify the prerequisites required by each piece of code and whether it's in place or not. And then you can specify, exactly what you require and write code for it, and pick and choose the code and deliver the entire solution at one go. Now, an automation playbook doesn't just provision infrastructure. It can be programmed to do many things, right? And if you think about it, what does an application migration require end to end, right? It needs, first discovery, which is what are the different applications that need to be migrated. Then it requires assessment. Each application needs to be assessed. Then each application requires a disposition as to what are we going to do when we migrate the application. And then it requires design. What are the different services on the public cloud that we are going to need? Is it an EC2, an EFS, an RDS, and serverless services, context-based services, and so on and so forth. And then that infrastructure needs to be provisioned. And then there are two more aspects to it. One is the data migration and one is the application migration. The application migration could be a lift and shift, for example, in which case we take an image of the virtual machine that is there on premise and then move it there. Or it could be a re-architecture, in which case we'll have to install the application from scratch and then test it out and so on. And then, of course, there's the data migration piece where we migrate the entire data from the on-premise database to the public cloud database. It could be an RDS or it could be something else. And then there is testing. Now, all of these things, most of these things can be very easily programmed into the automation playbook. So I could, discovery, assessment, and design will have to be done manually. I'm assuming, at least at this point in time, I don't know any kind of automation where design is done automatically as yet. And I'm sure that time is coming. Artificial intelligence is getting better and better, and design is going to be automated at some point in time in the future, or I'm not entirely sure if it is already being done. So, you can talk to me if you know any automation software that can literally design the infrastructure that is required. Talk to me about it. Let me know. I'd be glad to, understand how it's being done. So discovery, assessment, and design, I can understand that it's a manual process. But once the design is complete, a playbook can be designed that will essentially look at how many environments are required, what are the different services that are required on the public cloud, what is the disposition of the application. If it is a lift and shift, then things become very, very easy. It takes a snapshot of the images that are required and builds the snapshot on the public cloud. And if it is a re-architecture, then fresh infrastructure is provisioned. So that's not really that tough. As far as data migration is concerned, I'm aware of, Terraform code that can do that as well. Move the database from the on-premise system onto the public cloud into the RDS service. That's also doable. As far as application installation and configuration is concerned, now if it's a lift and shift, it's a piece of cake. You just take the image of this, take a snapshot of the image and then build that image on the public cloud. However, if it's a re-architecture, then there's the IQs and OQs. It's basically a step-by-step method of installing the particular application that we are trying to migrate from a scratch. Now, if we have a ready-made installation questionnaire, then that can be also automated. However, in my practical experience, I haven't seen that happen very effectively. Usually, there is manual intervention required, especially when it comes to enterprise applications, enterprise software. The installation process is rather complicated. Now, we document it in the form of IQs with snapshots and everything. But when we run it as a code, it doesn't always work. So, there might be some amount of manual intervention required, but we are getting more and more mature in that area as well. And then, so if we can do this much automated, right, starting from provisioning of the infrastructure to migration of the data to installation of the application, that is about 80 to 90% of the time taken to migrate an application. Right? And in my previous episode, we were talking about speed. The definition of speed is completely changing. Now, there used to be a time when migrating an application used to be a sequential activity. But once we have a cloud migration playbook in place, right? Once we have automated 80% of the most time-consuming activities when it comes to migration of an application, things become a lot quicker, right? I would be able to create a migration factory, right? Where we will do an assessment factory, a design factory, a mobilization or migration factory, and then a test factory, and then a production cutover, right? So we have multiple phases in that. Let's say a discovery factory. There are AWS tools available that can be installed onto the on-premise data center, which will essentially look at all the applications that exist within the on-premise data center. Now, we could sort of prioritize them based on the complexity of the application, based on the availability requirements and the confidentiality requirements and the security requirements of the application. And then based on that, we could do the discovery. So discovery to a certain extent can be automated. And then we will have to set up an assessment and design factory where each application will have to be individually assessed. Their dispositions will have to be identified, whether they need to be done, they can be shifted directly onto the public cloud or they need a refactoring. Now, one small point about this as well. There are many applications that will have to be that will have to be designed, right? There are sometimes we don't follow standard policies and processes. Like, for example, multiple applications accessing a single server. Now, this is not a standard practice. As per policies, usually from a security standpoint or from a dependency standpoint, it is not advisable that an application is sharing a database server with multiple other applications. Individually, each application should be isolated, right? It should be in its own own sandbox. So the application server, the database server are unique, and each application has its own database server. Now, assuming that we did not follow the standard practice and we have multiple applications accessing one database, if we have to lift and shift this into the public cloud, then that is not as per policy, and there's a good chance that the security team is going to deny this, right? So a refactoring is absolutely required. There are other cases when we can do a lift and shift. These are a little bit antiquated technologies, maybe an older version of the operating system, or an older version of the application itself, and a modernization might be required. Now, there are two approaches to this. Either we modernize everything, refactor everything, and move it to the public cloud, which is actually the ideal way of doing it if we have time in our hands. But let's say that we are hard pressed on time. In such a scenario, the standard process that is used is assess, mobilize, and optimize and modernize. What that means is we first assess, and then we just pick up everything and move it. We just lift and shift everything. And then we look at individual applications and see whether they are the best design that can be, right? Whether the applications that have already been mobilized now onto the public cloud, is there optimizations possible? And this is very, very important. Usually it is assumed that once we move an application onto the public cloud, it's going to be a lot cheaper. Well, it is cheaper in one way that we don't have to invest in hardware, and hardware is really, really expensive. So that way it is cheaper. We don't require an upfront investment. But when it comes to operational costs, when it comes to looking at the costs of maintaining that hardware, the money that we are paying the cloud service provider, whether it's AWS or Azure or Google's cloud or what have you, that will be very expensive if we are not properly utilizing the native services provided by the cloud service provider. So when we move applications onto the public cloud, one thing that we need to do is make sure that those applications are designed for the public cloud. They are designed utilizing the native services that the public cloud is providing. To give you a very, very simple example, a database on-premise is usually hosted on a virtual machine. So you have a virtual machine, and then you have SQL Server or Oracle installed on it, and then you have storage either in that virtual machine or separately, in a shared storage device or what have you. When you move it onto the public cloud as is, when you do a lift and shift of that, let's take the example of AWS. You have an EC2 instance, and then you install the database in that EC2 instance, and you run the database from there. Now, that is an expensive affair. The way to do it is set up an RDS service, right? That's a native service. So it's very important that once we have moved our workloads onto the public cloud, they be redesigned specific for that particular public cloud with the native services utilized. Now, one good way of doing it is assess, mobilize, and optimize and modernize, like I said before. But we have to be very careful that these are all a part of the same project. If we don't do the optimize and mobilize, it could become a very expensive affair. And there are a number of examples out there in the industry where people paid more than what they were paying for the on-premise data center because they did not, do the migration properly. So bringing all of this together back to the Agile infrastructure, right? Like I started by saying, if you want to do large migrations, mass migrations of applications onto the public cloud, one way of doing it is through a large number of people at the project. 50 pods, 50 applications, next 8 months. But that's a very expensive affair. A better way of doing it is build a tremendous amount of automation. Now, technology exists out there that could help us do that. When the infrastructure services team becomes a software development team, when it develops infrastructure as a code, when it develops software that essentially automates the process of doing migrations, that is called Agile Infrastructure. Now, Agile Infrastructure is a vast topic. Okay, this is not just it. This is one aspect of Agile Infrastructure. There are many different aspects of Agile Infrastructure, which includes MLOps and various other kinds of automation, RPA, RCA, and what have you. And we'll probably cover all of this in future episodes. But what I was trying to say in my previous episode is technology is expanding and organizations need to adapt. What I'm telling you in this episode is one way of how an organization can adapt to the changing technologies, improve speed, improve agility, and get better. I hope you've enjoyed this episode. It's a little bit that, that has the potential, that we have the potential of doing, that organizations have the potential of doing. But there's a lot more to this than just this. And if there are ideas that you have about this, if it makes you think about things that, that you've done at your work, and if you, would like to talk about it, then please reach out. Remember, Enterprise Architecture Radio is not just a podcast. It is a community. It is a tribe of enterprise architects. It's people getting together and talking. So join the tribe. Talk to us. Talk to this tribe of enterprise architecture communities. Learn from each other, collaborate with each other, and guide each other. But most importantly, have fun.